Hello guys, welcome to Statophysics. In this lecture series, I will discuss about interpolation. This series of lecture will be very helpful for students who have taken elective stat as their class 11 or 12 course along with statistics general undergrad students. Also from this part of numerical methods, many problems appears from this part in exams like JELET and other BTech Lateral Entry exam. So let's get started. Now, before learning what's interpolation, a question may arise amongst many of you that why we need a method called interpolation at all. So let's focus on why we need interpolation. Why? Now, while talking about why, just to recapitulate, I am giving you a basic of argument and entry. So, what is an argument? Suppose a function fx is given and for a certain value of x, suppose x equals to x, the value of the function is x. Suppose is xi. Okay. Now, here this fx, that is the independent variable, this independent variable is called argument, and this xi is called entry. So for any function, a argument will give you a entry. Okay. Now let's go back to our previous question. Why interpolation? Suppose we know, suppose you are given f of x is equals to sin x. Now for different values of x, like x equals to pi by 6, pi by 3, etc., you can calculate the values or the entries of fx or of fx. For these values, for these arguments, you can calculate the value of fx. But if we are given the arguments such as x1, x2, x3, x4, and we are given the entries, that is, suppose y0, y1, y2, and y3, and they ask us to find out the corresponding entry for the argument x5. Then using this data, we don't know the function at all, but using this data we can calculate this x5, and the numerical method that enables us to calculate from a given data set, a data set which has arguments and entry. Such kind of data sets, we can use interpolation method to calculate an unknown variable for an unknown argument, an entry of that given range. So this is interpolation, and I am giving you the definition of interpolation. The method of computing such computing an intermediate value of a function from a given set of values of the function is called interpolation. Now this interpolation thing, so before going to study interpolation, we should know the types. So interpolation are of two types. One is Newton's forward interpolation, and another is Newton's backward interpolation. Now every thing in statistics and physics and or in any subject needs needs a prerequisite. So to study this method of interpolation, there is a prerequisite known as finite difference. So what is a finite difference? Suppose we have been given some arguments and the corresponding entries. Now the finite difference is nothing but the difference between the successive entries. See, the difference between these two entries of the corresponding value x2 and x1 is the first order finite difference. So in this case, the first order finite difference will be denoted by this, will be equals to y2 minus y1. Now let's study it mathematically. Suppose a function y equals to fx is provided, okay, and the h, and we define the term h, which is known as the interval of differencing is introduced. So what is the interval of difference? So suppose x1, suppose we are given the entries x equals to 1, 2, 3, 4, 5. So we see that it's increasing by 1, by the same scale factor 1. So here the difference or interval between two successive arguments are called interval of differencing. Here the interval of differencing is 1 because it's increasing by 1 only by the same scale factor, right? So we had defined here h, that is, in case of the function fx, the arguments those that provided are increasing by h. Okay, thus we find the first order difference or first forward difference is given by, we denote it by del of fx. This del operator is called difference operator. Difference operator. So del of fx will be equals to what? Del of fx will be equals to, we know that the successive term minus the preceding term. So f of x plus h minus fx. I think it would be more simpler to understand using an example which I am using it later, but this is the mathematical theory which you should know, at least for those who are appearing for board exams, taking statistics as elective must know this fact. Okay, now the second order. So if you are accustomed with the differentiation, you will understand it very easily because these are the things which have the very similar properties, and when I will discuss the properties of this difference operator, you will see that it's quite similar, not exactly, but it's quite similar as the derivative we do. So now the second order difference. So what will be the second order difference? Second order difference is denoted by del 2fx, which will be equals to del of del fx. Now we get the value of del fx here, f of x plus h minus f of x. Now as the del operator has a distributive property which I will discuss it later, I will jot down all the properties of del. As for now, you just consider it has a distributive property, that means it can be distributed. So del of f of x plus h minus del of fx. Now here is two terms. Now think about it. If del of fx is equals to f of x plus h minus f of x, then del of f x plus h will be equals to what? F of x plus 2h, hence it is increasing by h only. So del of f of x plus h will be equals to f of x plus 2h minus f of x plus h. Just I am using a similar concept. So del of x plus h is equals to f of x plus 2h minus f of x plus h. Again, del of fx, we got it earlier, but I am writing it down again, and I am substituting these two in this equation 1. So substituting in equation 1, del 2fx is equals to f of x plus 2h minus f of x plus h minus f of x plus h minus fx. So what we get is f of x plus 2h minus twice of f of x plus h minus fx. Similarly, you can try it by your own, the third order and fourth order differences. You can try it. Okay. Now let's talk about the property. So the property of del operator or the difference operator. So why it is called operator? Many of you who are not accustomed with the term operator will get confused about operator. So what is the operator? Operator is nothing but a function, not a function. How to explain it? Operator is something that inculcates in itself the variable form present in its right side. Suppose an operator will operate. It will act like a boss to something which is in its right side. So here it has nothing in its right side, so it has no function. But if here is a function fx in its right side, then it will operate on its on this function. So these are called operator. If you are interested in operator, do comment below. I will make a video on that too. Now let's talk about the properties. The properties of this del operator is quite a bit similar with that of our derivative. So at first, if c be any constant, then if we operate del on c, it will give nothing but 0. You know, if you compare d by dx of c is equals to 0, so these are very similar. Okay, now again, suppose a function fx is given which is multiplied by a constant c. So this operator will act as del of cfx, which will be equal to c del of x. So it will not operate on any constant. Be clear. If there is a constant, only constant, then it will turn it to 0. If it is multiplied to any function, it will only it will only operate on the function and get multiplied with that constant. Okay. Now the third property is of the distributive property that I told before, which is true for both addition and subtraction. It is equals to, it gets distributed. Okay. Now here the multiplicative law is not that much similar to that of differentiation, but theoretically, in first look it didn't look so similar, but theoretically it's also similar. So it's f of x plus h, that means the succeeding term dot the first order difference of the second plus making the second function constant into first order difference of the first. Again, you can use it as gx of g of x plus h. So it will be like fx, making fx constant, dot del of gx plus g of x plus h dot del of fx. So these are the two forms, and there is also a division formula. So in JELET 2017 or something like that, in which year I don't remember, and also can't recall the problem, but I can remember at least a problem came just from this formula only. So it's like, who knows the formula, you will get it as a free mark. Okay, so these properties should be remembered, guys. Okay, so we have this. It's also quite similar to that of the differentiation in structure, but the difference term will get a bit different. So these are the properties. Now we can work out one example. Let's work out an example here using these properties. Suppose del 2, suppose it is given, find del 2 ux if ux is equals to 3x plus 2. So ux is a function given, and we are said to find the second order difference. Okay, so what we'll at first have to find the first order. Then del of ux is equals to what? Del of ux will be equals to u of x plus h minus x. Right. So we get this from definition, by definition. Now putting x plus h in place of x, just preliminary concept of function, what we will get? We'll get 3x plus 3h minus 2 minus 3x minus 2. So this will get cancelled, and 3h minus 4 will be our first order difference. Now what we see is that here it is plus 2. It is plus 2. Then these two also get cancelled, and we have 3h. Now this 3h term is entirely constant, so we got here what? The differential, if we operate a differential operator on a constant, it turns to 0. So del 2 ux will be nothing but del of del ux, right? So which will be equals to del of 3h. Now del of any constant is equals to 0. Therefore our answer will become equals to 0. This kind of problems are very common for both the board case and also the competitive case. Now let's move on to the next prerequisite that is also important, which is called the difference table or diagonal difference table. So what is a difference table? Suppose we have been, so let's work with the example. It's better to understand statistics in terms of example. I think so. So I am using examples. So here are the arguments, and here are the entries given. Okay. So the difference table, what does the difference table tell us? So if we want to find the any order difference using this, so we didn't give it, provided the function as before. They don't provided the function, they just give us the arguments versus entries, and they said they asked us to find, suppose, third order difference or second order difference. So how will we perform that? In that case we will use this difference table method. So what is the difference table? So let's jot down the difference table. X, so x are the arguments, jot down the arguments: x1, x2, x3, x4. And it's suggestion, guys, when you are practicing statistics, do all these kinds of tabular forms, because the tabular forms makes the computing very simple. Okay, now we will get the entries. So y1, y2, y3 and y1. So the first order difference del y is nothing but the difference between this, the difference between this, and the difference between this. So y2 minus y1, y3 minus y2, y4 minus y3. So these are the first order difference from the given set we can conclude. Now the second order, it will be nothing but subtracting these two and these two. So y3 minus y2 minus y2 minus y1, that will give us y3 minus 2 y2 minus y1, and these two will give us y4 minus y3 minus y3 plus y2, which will give us y4 minus 2y3 plus y2. Okay, just simply algebraic steps and del 3. Why? It is the third order difference. How will we calculate? We will just subtract from these two. So it will give us what? y4 minus 2y3 plus y2 minus y3 plus 2y2 minus y1. So after performing the algebraic addition, we will get this as the result. Now if we further want to calculate del 4y, it's not possible because it's the maximum difference we can achieve. And if we want to del 4y, if we want to calculate del 4y, this whole term is considered to be the constant, so it's naturally 0. So this property is also helpful in solving some problems which I will discuss now as an example. So this is called the difference table, and this is called diagonal difference table because see, it creates a nice diagonal pattern. It's like a diagonal. Okay, so this is called a diagonal difference table. Now let's focus on an example, and we will end the part 1 of interpolation here. So let's find an example. Let's make one example. Suppose it is given x, the arguments are given x. Suppose the arguments are 0, 1, 2, 3, 4, and the entries are also given 1, 3, 9, but this one is not given and 81 is given at last. Okay, so it is, they said us to calculate the value, the entry for the argument 3. So how will we proceed? We will proceed here with the diagonal difference table. So it is the application of diagonal difference table. Please observe. Let us assume for x equals to 3, fx equals to p. Let us assume. Okay, so we are assuming that this value is p. Let's just assuming it. Okay, now let's draw the difference table. X equals to fx, right? So 0, 1, 2, 3, 4, and here 1, 3, 9, p, and 81 p, because f3 is p. Okay, now the first order difference, as I explained it here, perform it. So the difference between this 2, the difference between this 6, the difference between this p minus 9, the difference between this 81 minus p. Now second order difference, the difference between this 4, the difference between this p minus 15, and the difference between this, that is 81 minus 90 minus 2p. 81 minus p plus 9, 81 plus 9, 90, and minus 2. Okay, and del 3y. Okay, so now we will calculate the del 3 by. So here the del 3 y will be p minus 19. So subtracting this, we will get 105 minus 3, and we will have the last one, del 4 y. Okay, so what will happen? Del 4 y, we will get 124 minus 4p. Now if we want to further differentiate it, it's see, it became constant. So del of any constant is 0. We discussed in the properties as a section. So here it became entirely constant, right? So if we further differentiate it, it will become 0. So we will use that property only. Okay, and we will say that 124 minus 4p equals to 0, right? Or so let's write formally here, that is del p it is del 4 is equals to 0, and then we put it 124 minus 4p is equals to 0, and what we will get is p equals to 31. So this is our answer. Okay, so this is our answer. So I described here the two topics, starting with the argument entry and everything. These are the prerequisite for interpolation, and in the next part I will discuss Newton's forward interpolation. Okay, so study this and subscribe if this video helps you a little bit, and I will recommend for those people who are just at 11 and thinking of studying statistics or their elective, must follow this series. Thank you. Have a great day.